and a very warm welcome to the 39th edition of the Tiscon eDiscovery webinar series. Our speaker for today is a very special one. He is Mr. S.J. Vijay, the founder and chairman of Salmon Leap Ventures, Home Mission India, and Space Sci-Fi Tech, which is a joint venture with the Indian Institute of Science. In 2011, Salmon Leap brought the 3D monolithic volumetric modular precast into India to manufacture, assemble, and install different building types catering to residential, hospitality, educational, logistics, and industrial sectors. Mr. S.J. Vijay has been a speaker at international forums and has been invited for knowledge-sharing sessions by countries like Singapore in the recent past. Salmon Leap and Home Mission contribute to the full spectrum from policy to on-ground solutions addressing the challenges of the surging Indian economy and its infrastructure. We extend a very warm welcome to you, Mr. Vijay, and we are thrilled to have you here with us to share your thoughts.
Good evening and thank you for the opportunity. I understand this is the 39th webinar you are holding, and there is a very special relationship what I'm going to share with you has with the Tata Group as a whole, Tiscon in particular. As we go forward, I would be delighted to share, how Tatas were instrumental in bringing not just a technology, a complete shift way back in 2015 and 16. For the first time in the country, thanks to Tata, we could demonstrate that the buildings need not be built. The buildings can be manufactured. We demonstrated, and it has grown. Today, not just the RCC buildings, we are striving to deliver all kinds of buildings, whether it is precast, whether it is prefabricated, whether it is 3D printed, in prefabrication, whether it is steel, whether it is cross-laminated timber, in precast, whether it is two-dimensional precast or three-dimensional precast, as well as 3D printed. All of it, this country needs because of the fact that we are becoming the third largest construction market of the world. And, it says discovery, and the intent is, can we discover what all has happened in the Indian construction market to shift construction from manual, fragmented, sequential to aggregated at one go. We can manufacture a whole room and install it at the site itself. To that level, what have we done? And when we do that, what does it offer to us, whether it is Tiscon, whether it is a Tiscon dealer, whether it is an architect or an engineer? What does it hold in stock for us? How can we accelerate this and consequently benefit as well as make a difference to the making the buildings and built environment? So, thank you for this opportunity. And if we are all ready, we can start off with a few slides which I have, which is what we collectively can discover. What have we done? What can we do? What difference can it make? If that is okay, we can go on to the presentation. All the attendees, good evening. And like I was telling you, let us together discover how we now in India have started manufacturing the building as a product. When we talk about manufacturing the building as a product, this manufacturing can happen as prefabricated, which means we make multiple elements in a factory, bring them together to the site, join them together to deliver the building. Or if we are using the concrete, we could start precasting different elements separately, or we can go into a three-dimensional precast of casting the whole room with all the four walls and the slab. Even before we pour the concrete, we can install all the conduits, the wall boxes, the fan hooks, all of it, and then take out the whole room. That is what we call as 3D precast. Or we take the 3D printer to the building site, like in cast in situ concrete, we can make the printer print to the building. So any of these routes is what currently is delivering buildings as a manufactured product. Now, when we do this, can we deliver the building faster? Can we deliver better buildings? Can this building be stronger? And most importantly, in Indian context, can we do faster, better buildings, stronger buildings without charging an additional premium? Yes, we can. And that is what we have done in the past about 10, 11 years. And that's the discovery we will get into now. So quickly, these are all the various ways the concrete buildings were made historically. Countries like Singapore wanted to give accommodation or the housing for every single citizen of the country. They used what is called as the two-dimensional precast, which means you manufactured columns, you manufactured beams, you manufactured wall panels, you manufactured roof panels in a factory, brought them all together to the site, joined them together to make one single room. And you made multiple rooms and you made the whole building. That was in use ever since the Second World War. And in Singapore for periods like 40 years, it was on. And it had its own advantage as well as the challenges. All the people in the audience, and we were talking about the level 2, how you can manufacture, let us say, an RCC building as column separate, beam separate, wall separate, and join them together to make one room. It had its own advantages. The challenges were too many joints, too many connections, and hence possibly extreme level of workmanship required, and managing these kind of a multiple pieces was proving to be a challenge in various ways. Hence, the industry moved on and said, can't we make the whole room and in one single pour, as one single piece without any joints, and then connect those rooms together to create the building? This whole movement from level 2 to level 3 began way back in 1997, but it got adopted in different continents and different countries gradually. As you know, in construction, everything has to be tested, proven, accepted before it is deployed. So this level 3 started happening somewhere around 2010 onwards. In Singapore, they call it PPVC, precast, pre-finished volumetric construction. In Singapore, they call it modular integrated construction. And in addition to making the 4 walls and the roof as one single pour, is it possible that we can also add the floor? If we add the floor, all the 6 sides of the room has been made, which means we can start putting whatever, whether the cupboards or the commodes or the whatever has to go into the room also can be installed in the factory. So in level 4, Singapore went to that level. That is why they call it precast, pre-finished volumetric construction. It can be prefabricated, pre-finished volumetric construction also. So what are we doing in India? We jumped straight into level 3. The 5 sides of the room can be manufactured in one single pour and can be made at the site itself and erected into a building. That's what I want you to discover today. I'm changing to the next slide now. I will now continue with precast, pre-finished volumetric construction. Like I said, these modules are 3-dimensional and they are freestanding. It doesn't require any propping. It doesn't require any support at the time of erection. It has internal finishes, fixtures, fittings, all can be done in the factory itself if it is a 6-sided module, and we can manufacture it either at site or away from site and bring and install. Now, obviously, all of you would have guessed there are lots of advantages. You could increase the productivity per person up to 40%. Today, we have increased it far higher. You would see, how did we do that? Since the Singaporeans did it in 2011-12 onwards, it's about more than a decade. We have changed a lot of things. Because it is manufactured in a factory, it is like a manufactured product. Quality is assured. It is not left to the hands and skill of the worker anymore. So if we have to do all of this, what is it that we had to achieve? We had to look at things right from the design stage itself. in these 10 years, we do have, those of you who are architects attending this, we today have a practice in architecture which is called design for manufacturing and assembly of buildings. In Singapore, they call it DFMA. Government of UK, involving 600 different companies, has now pulled out a rule book, not only designing for manufacturing and assembly, like automobile, can we create platforms for each type of the built environment, and can we have a common bin of parts? Yes, they have. Have we brought into the country? Yes, we have brought into the country. And where are we? We are trying to adapt it to the Indian condition. In the subsequent slides we see. So we, as far as the design is concerned, we have picked up good amount of traction in India. And this discovery for you and for us is, how do we inform and involve as many of you as possible, so that this picks up momentum and becomes the default. When we do this, obviously, it brings in efficiency, it brings down the cost, and also, how do we optimize the weight of the module so that current material handling cranes and other equipment are available and usable to deliver. And I'm sure intuitively you are guessing already, at the project management level, for making one room, you are making 10 different, you are not making 10 different elements. One room is one element, which means if there is 1,000 rooms in a building, it's only 1,000 elements you are managing. So you automatically reduce the complexity in project management, be it sourcing, be it tracking the project, be it erection, at all levels, order of magnitude efficiency comes in. And do we have standard practices documented and issued for this kind of manufacturing building as a product? It wasn't there about a decade and a half ago. It was still in the works. Today, all of them have become available from different countries and is being adopted for Indian situation. So having said all that as the background, let us look at it from the structural point of view, from the architectural point of view, and also from the MEP point of view. If we're talking about manufacturing building as a product, it is not just the structure, not just the rooms. Whatever has to go into those things also have to be designed for manufacturing, and the entire ecosystem has to be in place. Has it come into the country? Yes, it has come into the country. Has it come to the level that it is in Singapore? Not yet. Have we picked up momentum? Yes, we have picked up momentum. You would see in the subsequent slides how Tiscon, over these 5-6 years, has taken, as far as the reinforcement, joints, connection is concerned, how they have productized, how they have removed the need for tedious labor involvement. You would see that. And in MEP, similar things have been done. Can we have modularized MEP, which is available, which can be installed straight away? Yes. So as you see in the last column, PPVC, we have structural PPVC elements available. We have architectural PPVC elements, including ready-made bathrooms with all the plumbing lines available. We just delivered one yesterday for one of the large companies of India. And we are right now working on getting the MEP also modularized, so it becomes truly designing for manufacturing and assembling the building as a whole. That is where we are. So if that is the case, some of you who are engineers and architects there would be wondering, how do I get into this? What are the things that I need to achieve if I have to succeed here? Fundamentally, the 3-4 points which we need to do is, can we reduce the total number of components that make the whole building? If we have made it more and more integrated, a whole room, or a whole room with balcony as well, or a whole room with balcony as well as the floor, or a whole room with balcony, with the floor, as well as whatever has to be installed in that, the further we go, the lesser the number of components that has to be handled, which means it reduces the assembly cost. It reduces the work in progress. Otherwise, too many elements are WIP and their inventory holding happens. And when we do this, minimizing the number of components, it also enables automation or simplifies the automation. Now, another principle that we try to follow, which DFMA prescribes and teaches us, is how do we design it, not only for manufacturing and assembly, at the time of fabrication or at the time of manufacturing, how do we simplify the geometry of it without unnecessary non-functional features, which in conventional construction we have been adopting extensively. The more we standardize, the lesser number of molds we require, which automatically reduces the capital expenditure the project requires. So that is another principle we try to follow. One, minimize the number of components. Design it such a way. Number two is ease of fabrication. And then obviously, we also at the time of design think about how do we assemble them together? Do we optimize the module sizes and reduce the weight so that we don't need excessively high capacity of cranes? Can we design with easily, readily available connections? The structural connection elements were not available in India. Today, it is available from Tiscon. It is available from international entities who have now come into India, started manufacturing. So the whole ecosystem has matured to ensure or enable that we can not only design, we can manufacture, assemble. And then obviously, when you're designing, you have to provide for, what is the maximum tolerance that we can enable at the parts level. Room to room, when I'm joining together, I have to maintain the plumb. I have to maintain the P-line. What is it that we can do to ensure those things are taken care? And the need for adjustment should be minimized. In fact, if we can go with less than 5 mm tolerance, adopt the principles of manufacturing and the standards of manufacturing, yes. Now, all of you, particularly those of you who are the engineers and the architects already know, beyond the hype of BIM, we have now started actually using BIM, at least in projects like airports, in projects which are now coming up, like for the semiconductor. In these areas, we do use BIM extensively because the tolerance there is extremely limited. So, and in addition to all of this, how do we take into account the transportation requirement if we are not manufacturing at site? If we are manufacturing at site, we have more elbow room. Otherwise, we have to make sure the dimension of each of the element is as permitted by the Indian, motor rules. We have that examples of how they are moving on Indian highway, whether it is a windmill or the car manufacturers, move from the northernmost part of India to the southernmost part of India. So we do take these guidelines which are available there to size the rooms or the manufactured part of the buildings, and there we keep in mind the cost of transportation versus what is the value of the module we are transporting. So that dictates how much distance we can transport if we are going for offsite production. Okay, so that is all the design principles. Now, can we have one mold, one machine giving us different lengths of room, different heights of room, different wall thicknesses, different openings? Has the system matured? Good news is yes. Now, from the same machine, you can manufacture a 3-meter tall module or a 3.125 meter tall module or half the height module. Length can be full length, half length, 3/4 length. Wall thickness can vary from 90 mm wall thickness from the same machine to as much as 200 mm wall thickness. So the technologies or the methodologies that are now available in India permit all of that. So we don't need, a variety of machines to make each of the room. One machine can manufacture all these colors which you see because the machines themselves are flexible. So that is another thing I just wanted to share with you, because all these things may be running in your mind saying, how do I have different rooms from the same machine? Okay, is it only concrete that we are talking about? No, it can be a pre-cast or a fabricated module. If you are talking about prefabricated module, their structural elements are steel. The rest of it can be any other material, whatever is suitable to the business code, the seismic zone, and the climatic condition. Both are available. In the case of concrete, it is typically monolithic, one single pour. All walls and slabs are poured in one pour, no joint. If you're going into steel, obviously you need to have structural elements in steel, other material, which is sustainable, which is thermally, more efficient. You can use those things. How far have we come in 3D printing? I'm sure all of you are tracking. Today, we do have prototypes or example sample projects, whether it is a bus shelter, whether it is a single unit printed inside IIT or a post office. These things are happening. What is holding it back? Advantages, you can design a building, feed it into the system. This system will feed it into the printer, and printer will print the whole structure. What are the disadvantages? Can it take reinforcement? Not yet. Do we have, a high-rise buildings that can be manufactured and installed? Not yet. It will come right now. If you want a curvaceous shape, in all these examples which has been done in the country, you would notice these are all non-linear. Those things, the machine can be taken to the site and manufactured at the site. So if you, all of you here attending this, hundreds of you, and us, if we have to move the construction from labor-intensive, manual, sequential, fragmented into manufacturing with guaranteed quality, there are a few things that we need to do. We talked about design for manufacturing and assembly. We now can talk about, can we deliver the whole thing from procurement to planning and execution, handing over at one entity? Can it do? Yes, it can. And what are the technologies that are available? We only talked about one of them so far in detail. The rest of it is all maturing in the hands of different people and different entities. So has it gone beyond this, beyond DFMA? Has countries moved in and pulled in academic institutions, building material manufacturers, building product manufacturers, and have they all arrived at certain common rules to design for manufacturing and assembly? Have they started creating platforms? Have they written rule for platform? The good news is yes, we can share all of this. This is an effort by 600 plus companies, plus universities, plus governments. They have worked on this for 5 years. And this is what we have brought into the country through the joint venture with Indian Institute of Science. As you can quickly see, the rule book says whatever you are designing, creating as a platform, it should be deployable and it should be configurable as you need. And it should be as much as possible common repeatable elements. This is not new. This is what the manufacturing industry has been doing. This is what the manufacturing industry has evolved. It is just being adopted to the construction industry so that we can shift it from manual to manufacturing. The interfaces also have been standardized, and it should be open platform. It is not proprietary. That is why all these companies came together into the Construction Innovation Hub, created and made these things available. And the three critical parameters: one, it should be recyclable. It should be circular economy. What have they done to ensure? These are all laid out in this. And structured information. It should flow from one to another across the value chain, across different platforms without any proprietary hold. And the quality is key. This is what has already been achieved, and this is being brought into the Indian market. And if we further go into the details, I don't know whether we will have the time to dive into these. We could do a deep dive into what the Construction Innovation Hub has done. In essentially, first to start with, what are the demands that are available, which is crying out for this kind of design for manufacture and assembly. That's all I have to share. I'm very, very happy. I'm sure there are lots and lots of questions popping up in your mind. I'm very, very happy to take any amount of questions, and over to Tiscon team.
First question that we have is from Amrit. She wants to know which of these systems are eco-friendly.
Yes, it is as eco-friendly as a concrete building can be. The other elements of eco-friendliness is because we are avoiding waste, we are saving time, we are reducing the quantity of material. From those points, yes, it is relating to in comparison with other RCC buildings. Yes, they are. But if we want eco-friendliness by changing the material, then we have to look at the alternate material, embedded carbon, and the consequent sustainability criteria. If we refer it vis-a-vis concrete, yes, not significantly, marginally.
Okay. And what about the seismic performances of these buildings, sir? This is a question by Ravindra.
Like I said, you should take a look at the notification issued by Government of India, PWD. They have recommended this for all types of buildings, like I said, all heights of buildings up to seismic zone 4. If you are going into seismic zone 5, then the connection details which are there requires further strengthening. That is from the government or regulation point of view. But intuitively, as an engineer, as an architect, or even as a layperson, you would have noticed every single rebar that goes into the structure is cross-connected in both the directions. You know, the seismic resistance we bring by cross-tying the load-bearing elements. The columns are cross-tied. Here, every single rebar is cross-tied. Hence, by design, it tends to be far superior to face seismic challenges.
Okay. And when it comes to the design guidelines for such buildings, how different is it from the traditional design guidelines?
We can, standard guidelines. Only thing is, you optimize, maximize the standardization across the column grid. That's all we need. In a normal RCC building, all the elevation features are all add-on features. At the core of the building, we are only deciding on the space between the columns and what load they can take. The machine, when we manufacture the mold, we only capture what is the column grid you give. As long as there is some kind of a uniformity, the variation is limited to 1 or 2 or 3 types only, then there are 2 or 3 types of machines required. It doesn't impose any restriction on the designer. The designer has the full freedom. We only try to optimize the variation or minimize the variance. The rest of it, the technology is subservient. It is a servant to the designer. It doesn't impose. It actually enables the designer.
Okay. And when it comes to the life of such buildings, what is the life of such a structure?
So it is RCC. RCC buildings, whatever life they have, it is the same life. Here the connections are grouted connections or welded connections as per the design of the structural engineer. Nothing changes. In fact, it could be marginally longer, more than your normal conventional RCC building. The reason is, here it is shear wall. Here you have the reinforcement at every square foot of the structure. Like we discussed, they are cross-connected. And hence, you can, at the minimum, take the life of the building as that of the RCC or a little more than that.
Then what is the difference between a traditional structure versus the cost for building, modular precast?
Obviously, the cost when we brought this into the country was higher. Thanks to the support of Government of India, Ultratech, Tata Steel, many other people, today, we're very, very happy to share with you. We are able to deliver these buildings which are stronger, we deliver it faster, quality-wise better. Despite all this, we are able to deliver it at the cost of the conventional, not the, when I say conventional, I mean the, cost in situ, my one kind of a building. That's how we win the contract, because the tenders, like I said, it is still L1. Whether you match the cost per square foot, that is the question they asked. We are able to win. So in terms of cost, we have come to the level that we match the Maiwan cost of construction.
And another question by Mr. Subramaniam is that you said that the module is taken out in one day. So how is the strength attained in one day for the structure?
I did mention that the mold has a built-in curing system. So built-in curing system is one aspect. Second is in the design mix. The Ultratech team, what is the admixture they add? With these things, third point is, unlike in other precast elements, the handling stresses when it is a 3D precast is a little less. In 2D precast, the handling stress is more. So these three reasons put together, we are able to demold or take out the module somewhere between 12 to 14 hours because it has a built-in curing system. And we do have the cubes which sit inside the machine itself. We take out the cube, check for strength. As long as I have a 12 to 14 MPa, then I can take out the module. And that is one of the things which the concrete technologist plus the mold maker, what he has built in as a curing system, and the natural tendency of 3D modules not having higher handling stress. These are the three reasons what makes us. We can share the details. We can take down the name of Mr. Subramaniam and number, and we can share with him what is the kind of a design mix we use, what is the, how do we measure the strength and the temperature on an ongoing basis, and how we decide, when to demold. We can share those details because that is a discovery we need to enable.
So the last question that we have is, how are these modules connected with the foundation of the buildings?
Good, excellent. So again, because of the time constraint, I didn't go into those slides. Just to tell in very simple terms, the details are available. We can even share, if it is an engineering firm, if they would like to know what are the structural connection details, we can share the structural model and the different types of connections, including the ones which are being used for high-rise. In simple terms, the question is about how do I connect the module to the foundation. Foundation, let us say plinth beam is the part of the foundation to which we are going to connect the module. If 3 or 4 types of connections are available, if it is only a 15-story structure, 5-story, 15 meter, then option 1, we can do the welded connection, which means the reinforcement of the plinth beam is terminated onto steel plates. The size, the dimension, etc. is dictated by the structural modeling, design, and the engineer. And the module, when it comes down to connect to this, it has built-in welded steel plate on top. They come one on top of another, and that is welded. Number of plates, the frequency of the distance between the plates are all dictated by the structural model, and we do. That is 1. 2. Like conventionally, we let the reinforcement stick up, and the module, when it comes down, it has got the grout tubes installed, pre-installed. You let the reinforcement rod go in, and you grout it. But it is not a foolproof one. So the third option is, can you install a grout coupler into the module and let that, get the reinforcement rod, and then you grout it from bottom so that it's pressured. You don't have any cavities there. 3. 4 is, like you have the bolted connections in the reinforcement, whether it is a metro pillar and how do you connect them. Those kind of connectors are available, which are bolted connections, and that can be pre-installed into the module. Here is the reinforcement rod or a bolt which jumps up, and we put them together and connect. These details of what size, what kind of a material, what test they have gone through, all this is readily available, again as a manufactured product. So we can use any of those things. Of course, the structural designer is the key person who decides which connection, which type of connection, what frequency, is it one of them, or for the sake of bringing ductility, is it a combination of some of these connections? That is what is dictated to us, and that's what we follow.
Great. Thank you so much for joining us today, and even to the audience. I think they've been a very exciting audience, and they've really had some interesting questions. Unfortunately, we could not answer all of them, in this particular session, but we'll be sending it out to you. Do respond to us, and we'll share the responses even with the audience and the viewers today. So thank you so much for making this session a very, very successful one.
Thank you for the opportunity. And, I said upfront, I will tell you what was the reason. Tatas have been the key. I will repeat, Tatas are the ones who brought this technology. The first ever project was done for Tata Housing. Tata Steel is the one who moved in and worked with us to reduce the time in processing, productizing the entire reinforcement. And today we work with almost 5, 6, whether it is Tata Projects, whether it is Tata Realty, whether it is Tata Steel, we work with all of them. Our intention to deliver buildings as a product beyond concrete is also anchored on Tata. They have got metal buildings which is coming in, which is possibly coming into our portfolio as well. So I think time has come. We deliver buildings as a manufactured product, and that's the only way we can meet all the demand that is there in the country. Thank you for the opportunity.